What's going on, guys? This episode will cover everything you need to know about databases for the OCR Computer Science H446 specification. So let's begin with methods of capturing, selecting and managing data. So we've got section 1, which is going to be capturing data. So we've got manual entry, which is typing data into a system manually or using forms or spreadsheets, stuff like that. You've got the pros of this, which is customizable. We can control the accuracy of the data through manual entry. We have a con or a negative, which it's definitely time consuming, and it's also prone to human error through manual entry of capturing data. On the other hand, we have automated data capture. So we've got using sensors, we've got RFID, we've got barcodes, and we have optical character recognition. So the pros of this is it's fast, it reduces human error, and it can handle large volumes of data. The cons, on the other hand, are the initial setup cost and the maintenance that is required for the automated data capturing. We then have the process of selecting the data. So we can essentially query data using SQL or structured query language to retrieve specific data. For example, we can use select star from students where grade equals A. So this will select all of the data from the table called students where the grade equals A. I will go into more detail in SQL in a moment. But for now, filtering. We can apply a criteria to a data set to view specific subsets. For example, using filters in spreadsheet software to view data from a specific date range. We then have managing data, so database management systems or DBMS, software that uses a standard method of cataloging, retrieving and running queries on data. For example, we have MySQL and Oracle. Data backup and recovery. We have recovery, which is regularly backing up data to prevent loss, which is backup. And through the recovery process, we can have recovery strategies to restore the data after a failure, or if data is lost on a main drive or main storage. Part 2, which is going to be exchanging data. So this is the next part of the specification for databases. So data exchange methods, we've got EDI, which is electronic data interchange, which is the standardized format for exchanging business data electronically. It's used in supply chain management quite a lot as well. We've also got APIs, which are application programming interfaces, which is basically just a set of rules that allows different software entities to communicate with each other. We have, for example, we've got an API using HTTP methods like GET or POST. We then have data import and exports. We can use CSV, we can use JSON, we can use XML formats to import and export data or tables, database files through and between systems. This ensures compatibility across different platforms if we use the same format. Section 3 is going to be normalization. So we've got, first of all, we've got first normal form, which is ensuring that each column contains atomic values or indivisible values, which is basically saying that we have one value per column or space in a table. For example, we've got splitting a full name column into separate first and last name columns. Or, for example, if we have a names column or a number plate column for a car database, and we've got several number plates in one sort of table column. And we essentially want to make it so that everything is atomic. So we'll have a second column for, I don't know, second registration. We then have second normal form, which is 2NF. It builds on 1NF, ensuring all non-key attributes are fully functional dependent on the primary key. For example, removing partial dependencies by creating separate tables. So that's the key thing with 2NF, second normal form. It's removing partial dependencies by creating separate tables. So third normal form, or 3NF, we again build on what we have already. So we're building on 2NF, but we want to ensure that there's no transitive dependencies. So, for example, removing attributes that depend on non-key attributes. So we've got section 4, which is SQL commands. As I said, I'll get to SQL commands, and now here we are. We have our basic SQL commands, which are select. So basically this retrieves data from one or more tables. So we can have, for example, select name, comma, age, which will select name and age values from the table students, where grade equals A. And it's important where we have where, if we have say grade equals A, we need the A in actual apostrophes or speech marks, whatever you want. Insert, which is a second SQL command. We add new records to a table through insert. For example, insert into students, name, age, grade, values, John Doe 16, comma A. So we can literally insert brand new values into our table with our table name students. We can choose the columns, we can choose where we want it, and then we can just insert a new record essentially. We can update, which is a third command. This uses the word update, and we modify existing records, of course. For example, update students, where we want to update the student table, and we use the command set, where we set grade equal B, where name equals John Doe, for example. So we use update as the main part, students, which is the name of the table, and then we have set, and then what we want to set, and then where we want to set it to. So that's update. We then have delete, which allows us to remove records. For example, delete from students where name equals John Doe. We then have create table, which creates a brand new table. For example, create table teachers, where the name of the table is teachers. And then we can have the columns in that table all in brackets after create table teachers. For example, create table teachers, brackets, ID in primary key, comma name, comma subject, with the data types or whatever afterwards. So we've got number 6, which is going to be a drop table. This literally destroys the table. So it's a very simple command for dropping a table. It's just drop table teachers, or drop table students, or drop table vehicles. The command is drop, followed by table, followed by the name of the table. We then have interpreting and modifying SQL, which is understanding existing SQL queries and making necessary adjustments to meet requirements. Section 5 is referential integrity, which is one of the key parts in this database topic as well, which is just ensuring that relationships between tables remain constant. For example, we have foreign keys, which constraints to ensure that a table or a record in one table corresponds to a valid record in another. That's a foreign key, making sure that it has a purpose and it's not just on its own doing nothing with no purpose. That's referential integrity. We can maintain referential integrity by using foreign keys to link tables. For example, outer table orders, add constraint foreign key. So we can just add foreign keys, foreign key columns to our table to link tables together. Now that allows us to maintain referential integrity. Section 6, and the last section, I believe, in this topic 1.3.2 is ACID. So, ACID is basically four parts. We have atomicity, which ensures all operations with a transaction are completed successfully or none are. Everything is done or nothing is done. Making sure that the task is either completely done and everything's completely sent across or nothing is sent across. This ensures atomicity with our commands, processes, things like that. For example, if we've got a bank transfer system where both debit and credit operations are both going on, if we've got a debit and a credit process going at the same time, we want to make sure that they're both carried out and both successful if they go through. But if, say, the credit doesn't go through, then we're going to basically cost somebody money that they don't have. So we want to make sure that everything goes through smoothly and properly, and making sure that it's all within our atomicity rules. We also have consistency, which ensures a transaction takes the database from one valid state to another, ensuring no integrity constraints are violated. Isolation, which is the third thing, is ensuring that transactions are securely and independently processed. For example, transactions do not affect each other while running concurrently. So that's the isolation of transactions. We have durability, which is our last one, which is the fourth and last one, where we ensure that once a transaction has been committed, it remains so. For example, if data is saved, even if a system crash occurs immediately after the transaction. So that's just the durability of our transactions. So again, you can link back to the bank. If we have, bank transactions going on and the bank system goes down, we don't want to lose everybody's transactions, otherwise that's going to cause a lot of problems. So that's our durability of transactions. We've got to make sure that these things are saved and durable in the event of, for example, a system crash. Section 7, which is actually, I believe, is our last section here. Yes, just expanding on ACID a bit, we have transactional processing. The definition of transactional processing is handling a sequence of operations as a single unit of work. For example, we've got online shopping cart. When we add items to the cart, we update quantities and checkouts. They're all part of a single transaction. The benefits of this are we ensure data integrity and reliability. We can manage transactions. We can begin a transaction, which will mark the start of a transaction, of course. We then commit to the transaction, which saves all the changes made during the transaction, and we've got rollback, which allows all changes to be made and reverted. So we can revert changes made to, for example, our cart or our checkout page, whatever you're on about. Yeah, things like that, really. So I just want to give our closing remarks now. So that will wrap up everything we need to know on databases, pretty much. Of course, I can't display databases as this is a podcast, but I hope that I've explained everything within my best ability. We've covered methods today: capturing, selecting, managing, exchanging data, normalization, basic SQL, referential integrity, ACID properties, and transactional processes. So thanks for tuning in, guys, and happy studying.